Hello, my name is Katarzyna Siła-Nowicka and I'm a lecturer in GIScience in School of Environment.
I'm also a lecturer in computer science, and my name is Michael Martin.
And we would like to talk you through our new major, Geographic Information Science. So Geographic Information Science, it is a discipline that conceptualizes how to store spatial information, how to collect the data, how to analyze this data, as well as how to visualize it. The discipline, it encompasses quite a few disciplines together. So it takes a little bit from geography, from computer science, from transportation, maths and stats. And what's important to remember that almost everything that happens in the world happens somewhere, whether it is a political event, historical event, or just accident, it happens somewhere. So as you can see on the slide here, we can see how the intensity of the transportation looks like across the US. And on the second image, you can see how the Hurricane Irma was approaching Florida a couple of years ago. So by looking at these two images, you can see not only that it's important to know where and when things happen, but also how these things will potentially affect both environment and society.
So as we're beginning to see, GIScience is more than just a computer in a lab. We have devices in the field, we have satellites overhead, and all of these things come together as a meeting place where we can start to inquire about all the things that happen in the real world, but in a digital sense.
In GIScience, we study both natural environment as well as built environments and problems related with these two environments. So students in our courses will learn how to, for example, identify a perfect location for a new grammar school, the one that would serve the highest sort of number of population possible. We also will learn how to design the new routes for public transport, so new buses across Auckland in order to improve the current public transport. Also, because of the era we live in, most of the cities in the world are smart, which means that in these urban areas, there is a number of embedded sensors everywhere, both in the cars, roads, and traffic lights. And then we can collect all this data in order to analyze them to get better insights of what actually happening in the cities. So we can use this insight in order to improve the operations for the cities, which means that we will be able to, for example, decrease the time we have to wait at traffic lights as pedestrians, or we will be able to find spots, we will be able to find free parking spots in certain areas. As we live in the era where we are collecting movement data using our mobile devices, such as mobile phones or Fitbits or your smartwatches, we collect plenty of location data that allows us to study population dynamics. So we are able to understand where people are coming from, where they are going, and what they are actually doing in certain places. This, as you may be aware now, could be used to, for example, study the spread of disease. So we can identify, where people are going and how they potentially could spread a certain disease, which could be used to do the contact tracing. Furthermore, we won't only be using sort of movement data in our classes, but we will also use various environmental data sets in order to, for example, predict how the pollution of in different areas of the city of Auckland will change, and how we can use this pollution data in order to quantify and calculate the exposure individuals would get. So it's not only the movement data and the data from the sensors that you are using that are only terrestrial. We would also be looking at the wide range of sensors that can capture remote sensing data. And these sensors are either spaceborne, airborne, or terrestrial. And they allow us to collect satellite or aerial data that could be used for various different environmental problems, to understand different environmental problems. By using these images, we can, for example, study natural hazards. So we can identify where possible landslides could be, or we can predict where this landslide will be in the future. Furthermore, by combining digital terrain model data with satellite images, we can simulate where the flooding would have the highest impact on certain urban areas. And we can create different emergency zone maps in order to inform people where these zones would be. Furthermore, we can identify land cover changes from satellite images, which could be used, for example, to identify the deforestation level. And we all be sort of learning how to do these things. Furthermore, we are able to use data from the drones or from different airborne devices with thermal cameras to understand the heat loss from the buildings. And it's quite an important thing in Auckland, knowing how badly insulated our houses are and how much heat we are losing.
Studying GI science at the University of Auckland is more than just sensors and data. We use different types of sensors in lots of different environments. We use drones to capture elevation models, but we like to look at them for more than just those purposes. In these two slides, what we're doing is we're using a drone here to get some elevation information about this landscape. And in the other image, we're actually in someone's property in Titirangi outside of Auckland, taking some videos in 360 3D environments so that we can actually tell the stories of Kauri dieback. What these types of sensors and this information gives us is a wide range of experience. So in the one image here, we've used that elevation data and combined it with a 3D model and a visual rendering software to create compelling images that on first glance, you can't tell that it's not real, but that was created entirely with software. In the other image here, you're seeing some of that 3D capture being brought to life in visual reality so that we can know not only what's happening in a place, but correlate that with different data sets to see how these tell the stories of Kauri dieback or how people know forests. Another type of data that we like to work with is social information. So this is Twitter data that we've collected. We have over 1 billion postings in some of these data sets. And traditionally, they're just seen as these dot maps, which you see in this image. And while dot maps tell us one type of story, they don't tell us really what's going on in the data set other than seeing individual posts that we click on. One of the projects we're working on allows us to create our own software to actually start to investigate these data sets. So what you see is this program here that has all these different ways of teasing apart what's going on inside it, so that we can create maps like this one that don't just say what the individual posts are, but summarize them using machine learning and artificial intelligence. So GI science is more than just data about the world or about soil information. It's a multitude of different domains. As I said, there's social media. Look, I'm working on something in obesity using machine learning. We have climate data, agricultural. We have participatory methods that work in different contexts from the global north to the global south. Mobile phone data, hazards, international development, and so many more. Studying at the University of Auckland in a GI science major will develop your skills in a large number of career opportunities. So we have skills in environmental consultancies, transport consultancies. We also have ideas of prediction and monitoring hazards, prediction of crime. It also leads towards great careers in teaching and data analysts or data science, and so many more. And what's important about this is it's actually on the long-term skills shortage for New Zealand. So there are actually more jobs for these skills than there are people to take them. So by taking your career in this direction, you're almost guaranteed a job.
Studying GIS and learning various geospatial skills brings you a set of new sort of skills and usually brings your understanding of spatial concepts and understanding of data to the next level. On this slide here, you can see the advice and the opinions about adding to your curriculum GIS-related subjects from various people who've done it before. Amit, for example, he said that learning GIS became an integral component of his sort of current job, and it allows him to use all his skills in working for banking and some insurance sectors. Tanya, for example, she thought that using this, like learning geospatial skills, it allowed her to view sort of data and different approaches on from a different perspective, and their general advice and advice from many people is that just by adding GIS to your curriculum, it just will enlarge the set of your skills and your possible employment possibilities. So our GIScience major has three main pathways. So you can combine it with either computer science, statistics, or urban planning. And you can choose whatever option you would want. In the first stage courses, there is one sort of GIScience core course, which is called Geographical Information and Spatial Thinking. And apart from these courses, you would have to take one of two geography courses, which is Geog 1 and Geog 102. One is more on sort of environmental aspects of geography. The other one is more related to human geography. So depending on your interest, you can choose one or the other. And then the other courses that you would be interested in taking will depend on the pathway you are interested in taking. So whether it will be urban planning, statistics, or computer science, it will be up to you. And your choice in the first year is not definite, so you can change it at later stages of the course. Okay, let's get into details now. So how much money we can actually make after, graduating from GIScience. So the basic jobs start more or less from 60,000 a year, and these are like GIS analyst or GIS consultant. And these jobs you could find a job like this either in council or for GIS consulting companies. If you add a bit more sort of possible programming to it, your sort of initial salaries would start from $80,000-$90,000. And then the more sort of experienced you are, you can look at salaries like, $200,000. What's important here is that I've just checked the other day that in the last 20 days, there were 52 new jobs that had GIS or GIScience in the title of the job. So, which means that there is quite a lot of possibilities there.
Taking a full GIScience curriculum doesn't mean that you can only take certain types of courses. Taking a double major is something that a lot of our students do. So if you're interested in geography, geophysics, earth sciences, environmental science, anthropological sciences, global studies, biological sciences, chemistry, marine sciences, any number of other double majors is totally open. So whatever your interest is, GIScience can find a happy medium for you. Thanks for viewing our presentation. If you're interested in GIScience, please apply at the University of Auckland and join us.